Hi Geometry, this is Ms. Strauss. I'm going to be going through 6.5a with you today. 6.5 deals with the properties of special parallelograms, and in this section today we're going to be working with rhombuses. But before we get into that, let's start with a warm-up. We want to find the value of x so that this quadrilateral that we have is a parallelogram. So go ahead, pause the video, give this a whirl, and then when you're ready, hopefully this is what you got for your answer. We know that for quadrilateral to be a parallelogram, the opposite sides have to be congruent. So that means that 4x plus 2, that side length has to be the same side length as 6x minus 10. The x plus 8 has to be the same length as the side across from it, but since we're not given a side length for this one, that one's not really applicable to our problem. We can use the 4x plus 2 and the 6x minus 10 though. So we set those equal to each other, adding 10 to both sides and then subtracting 4x from both sides. We end up with 12 equals 2x. Working through some division there, x equals 6. So now that we are warmed up to parallelograms and getting back in that mindset, we want to find the diagonals of a rhombus here. So we are told that ABCD is a rhombus, and we want to find the measures of angle 1, 2, 3, and 4. Since we have a rhombus, we know all four sides are congruent, and that is marked on there with the little tick marks. We also know, since we have a parallelogram, that the diagonals bisect each other. So that means BE is the same length as DE, and AE is the same length as EC. So we've got those tick marks in there. Now we have 4 congruent triangles. So you'll see that inside here we have 4 triangles. Each triangle has a tick mark of a side length with 1 tick, 2 ticks, and 3 ticks. So we know they are congruent by side, side, side. Since all of the angles 1, 2, 3, and 4 fall between the sides that are marked with 2 and 3 tick marks, that means that they are corresponding parts of our congruent triangles. And we know that corresponding parts of congruent triangles are congruent, so that implies that all of these angles are congruent to each other. So angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. They all have to have the same measure. We see that all of these angles, are supplementary to each other. So if 2 angles are supplementary and they have the same degree, that means that they all have to be 90 degrees. So since they are all 90 degrees, they are all right angles. So our answer would be that the measures of angles 1, 2, 3, and 4 is equal to 90 degrees, all 4 of them. So something to keep in mind. We'll circle back to that in a little bit. Now we want to find another properties of the diagonals of our rhombus. We have another parallelogram, and we're told it's a rhombus. We want to find how angles 1, 2, 3, and 4 are related to each other. So 1, 2, 3, and 4 are in a different spot this time, but we're going to find some cool properties about these. Remember that since we have a rhombus, the opposite sides are parallel. So that means LM is parallel to KJ, and then KL is parallel to JM. So now we're going to have to dig back in our mind to think about those properties of parallel lines and the angles that are created by them. So if we look at angles 1 and 4, we have them on opposite parallel lines, and then they're on the opposite side of this transversal LJ. So we can say that angle 1 is congruent to angle 4 by alternate interior angles. It's like we taught that for a reason. I know, it's coming back. We also know that JL is parallel to itself. Remember, we call that the reflexive property. It's parallel to itself. Bireflexive. So now we have two triangles that are congruent because we have an angle here, and then we have side, side. I'm going to mark in this angle. So since this line is parallel to itself, we have side, angle, side. We know that corresponding parts of congruent triangles are congruent. So if we look at these triangles, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Since 1 is congruent to 4 as well, that means that 4 is congruent to 2. And then since 3 and 4 are congruent, 3 is congruent to 1. So all of these angles are congruent to each other. So angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4, all by the transitive property. Let's go through some more examples of this. We want to find the length of WY. So looking at this one, we know that these angles are going to, or these diagonals are going to meet at a perpendicular. So we have a 90-degree angle here. We know this is equal to 5 because we have our opposite sides that are congruent. Now let's take a look at just this triangle in here. We have a right triangle. We need to find this side of it. So, because then these two sides are going to be equal, because our diagonals bisect each other. Our hypotenuse is 5, so let's set up our Pythagorean theorem, one of the best theorems in all of math. We have 5 squared is equal to 3 squared plus b squared. 25 is equal to 9 plus b squared. Subtract 9 over 16 is equal to b squared. And we get 4 equals b. One of our nice Pythagorean triples we call that when we get nice numbers. So we get 4 right here. We double that for the whole length across. So 2 times 4 is equal to 8. I want you to go ahead, pause the video, and then give the second one on here a try. Think back on the properties that we worked on the last couple problems. When you're ready, press play, and I will walk you through it. All right, well, let's see. We know here, if we look at just the triangle PRQ, we have two sides that are congruent, so we have an isosceles triangle. That means P and R have to be equal to each other. So if we take 180, we subtract 70, we're left with 110 degrees for these two angles. Since they have to be equal, 110 divided by 2 gives me 55 degrees for both angles. We're looking for RPS. So this is the angle that we're looking for. We learned in our last slide that our diagonals of a rhombus bisect the opposite sides. So this angle here is going to be congruent as well. So the measure of RPS is also going to be equal to 55 degrees. So now that we've worked through some problems with this, let's put them into a theorem statement. We have theorem 6.16 and 6.17. So theorem 6.16 tells us that if a parallelogram is a rhombus, its diagonals are perpendicular bisectors of each other. So putting this into a visual form, if we have this poorly drawn rhombus here, and all four sides are equal. Let's say W, X, Y, Z. And we have our diagonals right here. So if all four sides are equal and parallel to each other, or parallel to the opposites, then we know that WY is perpendicular to XZ. Theorem 6.17 tells us that if a parallelogram is a rhombus, then the diagonals bisect a pair of opposite angles. So, again, I'm going to give you a very poorly drawn rhombus. It's the classic teacher joke of, I teach math, not art. Yeah, that's where I'm at. So we've got all four sides are congruent. We have our diagonals right here. Let's call this 1, 2, 3, 4 down here, 5, 6, 7, 8. So if all four sides are equal here, then angle 1, angle 1 is congruent to angle 2, which is congruent, I am struggling, to angle 3, which is congruent to angle 4. And then 5 is congruent to 6, which is congruent to angle 7, which is congruent to angle 8. So those diagonals bisect the opposite angles. Let's do some more examples of this. Let's use these theorems. We are told quadrilateral ABCD is a rhombus, and we want to find the measure of ADE. So we want to find this measure right here is our mystery angle. Since we have a rhombus, that means AC bisects the angle ABD. So if this angle right here is 53 degrees, this angle right here also has to be equal to 53 degrees. We also know that BD and AC are perpendicular bisectors of each other. So this angle right here has to be 90. If we look at this triangle, we now have two angles of a triangle, and we're looking for the third one. We just have to set them all equal to 180. So 180 is equal to 53 plus 90 plus the measure of angle ADE. This gives us, if we do some math here, 37 is equal to the measure of angle ADE. I'll do one more with you, and then I'll give you a few to try on your own. We have quadrilateral GHJK. It's a rhombus, and we want to find GH. So that is our mystery side. We know here that our perpendicular, or our diagonals of a rhombus bisect each other. So we know that 2x plus 3 has to be equal to 4x minus 7. Adding 7 to both sides and subtracting 2x, we get 10 is equal to 2x. So divide both sides by 2, we get 5 equals x. Since we have a rhombus, we know HJ is equal to 3x plus 1. So GH also has to be equal to 3x plus 1. We know x is 5, so we can say 3 times 5 plus 1. And that will give me 15 plus 1. GH is equal to 16. All right, we've got 2 more problems left in this section. I want you to go ahead, pause the video, and give these 2 a try on your own. When you're done, press play, and I'll walk through them with you. All right, first one, MNOL is a rhombus. We're looking for the measure of MNO, so let's identify that angle first. So MNO, we are looking for this whole angle right here. That's our mystery angle. We know that LMO is 62 degrees. So if I don't hit the next button, we can identify a few more angles with 62 degrees. That means this one is 62 right here. This one is also 62. This one is also 62. So let's start by just looking at this triangle right here. We know that this is 90 degrees. So if we want to find just this little chunk of the triangle, we can take 180 is equal to 90 plus 62 plus this would be the measure of angle MNL. Solving this out, doing some addition and subtraction, we get 28 is equal to the measure of angle MNL. We don't want just that little sliver though, we want the whole thing. Since this line, LM, bisects this angle, LNO is going to be the same measure. So we can just go 2 times 28, and that will give me 56 degrees as my answer. And our last problem of the video, we have QRSP is a quadrilateral. We want to find QT. So just that little piece right here. Since we have a rhombus, all 4 sides are equal. So we're told that PS and RS are 3y minus 1 and 2y plus 3. Subtracting 2y from both sides and adding 4, we get y, or adding 1, I'm sorry, y is equal to 4. So that means that the side length here is equal to 4. All of them are equal to 4. So since we have y, we can plug that in for the whole length of QS. So 4 times 4, or 5 times 4, I'm sorry, 5 times 4 minus 4, be 20 minus 4 is 16. We know that the perpendiculars bisect each other, so that means that QT is exactly half of QS. So QT is equal to 16 divided by 2, which is going to give me 8. That's all I've got for you on 6.5a. Go ahead and work through the Pearson and join me tomorrow for 6.5b.